All right, Algebra 1, we are going to talk about a little more formally about these absolute value inequalities that we started to see in Zoom yesterday. Kind of a big topic. I wish we had more time to spend on it. We're going to keep it really simple and run through these absolute value inequalities. If I asked you to tell me all of the numbers for x so that the absolute value of x is equal to 3, you would tell me those numbers. Obviously, we're 3 and 3. We've become experts at solving these absolute value equations. But what if I asked you for all of the numbers whose absolute values are less than 3? Well, let's think about what that means. All numbers whose absolute values are less than 3. Well, let's see. Number 2 has an absolute value that's less than 3. And the number 1 has an absolute value that's less than 3. The number 0 has an absolute value that's less than 3. Also, the number -1 has an absolute value that's less than 3, right? The absolute value of -1 is 1, which is less than 3. -2, same thing. How about -2.5? And -2 3/4 and -2 5/6? All of those points in between, right? All of those numbers have an absolute value that's less than 3. And that looks a lot like one of our and statements when we talked about compound inequalities, right? I would not include the endpoints there, so not include -3 and 3. So my final answer would be this inequality. So we want to keep this in mind. An absolute value that's less than, an isolated absolute value that's less than a value is like an and statement. We should be able to write our answer like we wrote an and statement with that compound inequality, that squished together inequality, okay? It's all of the numbers whose absolute values are less than that number. Less than is an and statement. Less than is an and statement, okay? Or we could say, I have all kinds of little ways to remember this, sandwiched in between those two endpoints with an and statement, okay? Less than is an and. If, on the other hand, I asked you for all of the values for x whose absolute values are greater than 3, all the numbers whose absolute values are greater than 3, well, let's see, the number 4 has an absolute value that's greater than 3, and 5, and 6, and 7, and all of the numbers in between there. But also at the negative end, right? The absolute value of -4 is greater than 3. The absolute value of -10 is greater than 3. All of these values as well. So not including the 3, not including the 3, but all of those numbers on towards the ends of the number line, right? This looks like an or statement. In fact, we solve these like we solve an or statement. A greater than is like an or statement, or more than, right? More than is an or. So you need to remember which is which. Less than is an and, more than is an or. Our solution here would be x is greater than 3, or x is less than -3. Remember, when we write an or statement, we always include the word or, okay? So with these inequalities, we have a few steps we're going to go through. First thing we want to do is make sure that absolute value is isolated, okay? And it is in this case. The second thing we're going to do is decide, is this an and or an or? Because this is less than, this should be an and statement. So I'm expecting something like this. But what we're going to do is we're going to set up the two cases as though this was an equation. We're going to find those boundary values. So what number is there? What number is there? And then we're going to test points around those boundary values and see if those inequalities work or do not work. So my steps are going to be, I'm going to treat this like it's an equals instead of an inequality. So 2x minus 1 equals 7. 2x minus 1 equals -7. Now when I'm doing this, again, I'm finding those boundary values. Where on the number line are things broken up? And if I solve, I'll add the 1 and divide by 2. So x equals 4 would be one boundary value. Adding the 1 and dividing by the 2. And -3 would be the other one. So on my number line, I have something going on at -3, and I have something going on at 4. These should be closed circles because it's less than or equal to. That will not change. That's never going to be affected by any of the work that we're doing here. So mathematically, what we should do, and we'll do this with in other places in math, is those boundary values break up this number line into three places. This place, and this place, and this place. To the left of the -3, in between the 3 and the 4, and to the right of the -3. So what technically we should do here is we should test a point in each region. Let me check a point down here in this region to see if that part of the number line is covered by this inequality. So let me try a number like -5. If I substitute that -5 back in the inequality, the original inequality, 2 times -5 is -10, minus 1 is -11, but when I take its absolute value, I get 11. That is not less than or equal to -7, so I'm not going to color that end of the number line. It's not part of the solution set. If I pick a number between -3 and 4, nice easy one to use is 0. Absolute value of 2 times 0 minus 1 is -1, and its absolute value is less than or equal to 7. So I am going to shade this part in between because every number that's in that region is going to act the same way that 0 did. Now I'm going to do the same thing with a number up here. Let me try 10. Is the absolute value of 2 times 10 minus 1 less than or equal to 7? Well, now it's 21 when I take its absolute value not less than or equal to 7, so I'm not going to shade that part of the number line. Okay, so what we did is we found those boundary values, and then we picked a point in each region to test them, and then we shaded the parts that made that inequality true. So here's our little dirty little secret here. I've told you that an and is going to look like this thing does. An and is going to look like this. There are some exceptions to that. There's some special cases. We're not going to cover them this year. I don't care about them. We don't have time to cover them. So for the most part, if you can find those boundary values and know that it's a less than, it's going like that. Okay, I just wanted to show you that. Make sure you've seen it. So here's an isolated absolute value that's a more than. This should be an or statement. We're going to expect that it looks like this. I'm not going to go through too much. I'm not going to test these points. You can trust me or you can test them yourselves. But we're going to find our boundary values. X minus 2 equals 5. X minus 2 equals -5. And solve by adding the 2 would give me x equals 7. And if I add the 2 here, I get x equals -3. My boundary values, I recognize that this is an or. -3 on the left, 7 on the right. I've got open circles. It's an or going that way. Okay, so find the boundary values. Think about ands or ors. There's a whole lot more to this. We're not going to go any more deeply into it than that. So our steps for solving these inequalities, first thing we need to do is isolate the absolute value. I didn't show you any earlier that had anything outside the absolute value symbol, but like with the equations, you want to move anything away from that absolute value before we solve. Next step would be to decide if it's an and or an or. And again, we remember that less than is an and, more than is an or. We'll set up then those two cases to find the boundary values. And we should be testing a point in each region to find out what the graph of the solution set looks like. However, again, for our purposes this year, less than will look like an and, greater than will look like an or. So that's all we're going to cover for today, just these simple ideas. I want you to practice some problems from your book. Look in Schoology, I have the page number and the questions there. Tomorrow we'll just do a few more that are a little more complicated, just in terms of being longer. And then we'll look just briefly at special cases. We're not going to, I won't hold you to special cases this year. Okay, so we're just going to practice these, isolate, decide if it's an and or, set up the two cases, and then just shade. Okay, and that's it for today, guys. Have a good day.